In this video, we're going to talk about some things that can go wrong when we try to solve rational equations or equations with fractions in there. So, one of the issues is that the method that we have been talking about for solving rational equations involves finding the LCD, the least common denominator, and then multiplying through the equation on both sides by the LCD in order to eliminate fractions. And if your LCD contains a variable, then you don't really know if that violates the multiplication property or not. Remember, the multiplication property says that you can multiply both sides of an equation by any number you like, and except for zero, right? If you multiply through by zero, then what ends up happening is that possibly changes the solution set. Okay. So when you multiply with multiply both sides by an LCD that has a variable in it, you don't know ahead of time whether that's equal to zero or not. Okay. So what you've got to do is go back and check your solutions. At the very least, what you need to do is to check your solutions by plugging them into the LCD. If they make the LCD equal to zero, then you have to throw those solutions out. Okay. So you can do everything perfectly and fail to get the correct answer if you don't check. All right. And like I said, at the very least, you need to plug those solutions into the LCD and check those answers. So that leads us to the general steps for solving equations with fractions. First, what you want to do is find the LCD. Next, multiply both sides of the equation by the LCD, right? And so that is going to clear out the fractions when you do that. You're going to solve the equation that you get by doing that after you have eliminated the fractions. But really, those will only be possible solutions to your equation, okay? So what you need to do is check the possible solutions by plugging them into the LCD. And you've got to throw out any solutions that give a zero when plugged into the LCD. Okay? All right, so let's take a look at putting these into practice for this equation right here. All right, so we have 1 over 5x minus 2 over 9x equals 1/15. Okay? And we want to solve that equation. Okay, so the first thing we need to do is to find the LCD of these fractions in here. Right, this equation does have fractions, so we want to find the LCD. We are looking for the first off, for the number part of the LCD, we have a 5, a 9, and a 15 in our denominator. So starting with the largest number, which is 15, we would ask, hey, does 9 go into 15? And the answer is no, it doesn't. Right? 5 does, but all of these numbers need to go into the LCD. So that means 15 is not the LCD. Okay, so the next number that you would look at is 15 times 2, which is 30. And 9 doesn't go into 30, so it can't be 15 times 2. When I do 15 times 3, though, that's 45. All right, and 9 does go into 45 5 times. Okay, and 5 goes in as well. Okay, so the LCD is going to have 45 in it. Okay. And looking at the variables that I've got an x, okay? And so the LCD is going to have at least one x in it. So now here you might be tempted to add another x into the LCD, but it doesn't need to have another x in here, right? It's not the total number of x's that appear in the denominators. You don't need that many. All you need is the number of x's that are equal to the most number of times that x appears in any one denominator. So for instance, here there's 1x. In this denominator, there's 1x. And in this denominator, there's 0 x's. Okay? And so the biggest number between 1, 1, and 0 is 1. Okay, and so therefore the LCD needs to have 1x in there. All right, so the LCD is a 45x. In the next step, we are going to multiply both sides of the equation by 45x. All right, so multiply the left side by 45x, and we're going to multiply the right side by 45x. All right, then we are over on the left-hand side going to distribute that 45x to both of these terms. So we'll have 45x times 1 over 5x minus 45x times 2 over 9x. On the right hand side, we don't have to distribute because we only have one term, and we can reduce that, right? We know because 45 is the LCD that 15 is going to go into 45, right, 3 times. So 15 goes into itself once, it goes into 45 3 times. So we have 3x times 1, which is just 3x, and that would be over 1, which I'm not going to bother to write because we can just write it more simply as just 3x. All right, next up over here, I'm going to do some simplifications, right? First off, 5 goes into itself 1 time, and it goes into 45 9 times. All right, and then not only can I cancel that, here I have an x in the denominator and an x in the numerator, so they cancel each other out. And I'm just left with a 9 when I do that. 9 times 1. And remember, if simplifying these fractions is confusing, you can always write this as over 1. Okay. So on the top, I have 9 times 1. On the bottom, I have 1 times 1, right? So that's 9 over 1, which is 9. All right, next up, I have 9x and 45x. So 9 goes into itself 1 time, it goes into 45 5 times. And then I have an x here and an x in the numerator, so they cancel each other out. So on the top, I have 5 times 2, which is 10. On the bottom, I just have a 1 left over. So 10 over 1 is 10. All right, so multiplying through by the LCD cleared out the fractions. And so now I can just solve this linear equation. So over on the left-hand side, I've got some like terms. I can combine those. Remember, I'm trying to make each side as simple as I can possibly get it. 9 minus 10 is negative 1. And then 3x is as simple as I can get it. Okay, so now I've got both sides as simple as I can possibly get it. The next step or next mark that I want to hit is I want every term with an x on one side, every term without the x on the other side, and you can see it's already like that. So here in this case, there is no need to add or subtract to both sides. All the x's are on the right, all the terms without an x are on the left. So the final step would then be to divide both sides by 3. And I get negative 1/3 equals x. Okay. Oops. Looks like it's lagging a bit. There we go. Okay. So I get x equals negative 1/3. All right, so right now, remember, when you multiply through by an LCD that contains a variable like we did here, this is only a possible solution, okay? All right, and now to check that solution, what we would need to do is go over to the LCD, right, and plug in a negative 1/3 here and see what we get. As long as this doesn't come out to be 0, then that negative 1/3 is a solution. And it definitely is not a solution, right? Um, when you do that, you'll get negative 45 over 3, which is equal to negative 15. All right, here we kind of even knew a positive times a negative is going to be a negative. So even without doing the arithmetic here, we kind of knew that, you know, that we weren't going to get 0. Okay. All right, so that means in this step, when we multiplied both sides by 45x, we didn't violate the multiplication rule, right? Which says you can multiply both sides of an equation by any number you like except for 0, right? And the solution set will still stay the same, okay? So that means that negative 1/3 is an actual solution. So the solution here is negative 1/3, okay? And that's it for this one. All right, we'll do a few more examples here, but again, this is mandatory. You must check at least this much, because even if you did everything perfectly, you can still come up with answers here, right, that are not correct if you multiply through by an LCD that contains the variable.